viel mehr Informationen drin hat im Betriebssystem. Dementsprechend kannst du auch ein int reinmachen oder ein Void Pointer oder irgendwas anderes oder ein kleines Struct oder keine Ahnung was. Und was dann aber tatsächlich benutzt wird, ist nochmal eine ganz andere Story. Also, wie gesagt, das hier ist die Integer-Seite, das hier ist die Datenseite, die hier drin benutzt wird. Da werde ich noch auch ein paar andere Sachen geben. Ich glaube, ich lösche das jetzt hier mal weg.
Ich hoffe, das wird dann gleich klar. Ich will morgen mit getNextLine anfangen.
Damit wollte ich genau jetzt weitermachen.
Und ich hoffe, dass es dann einen Vorteil bringt.
Tatsächlich, da werde ich jetzt auch gleich drüber sprechen. Das kommt
Ich
gleich
habe
noch.
Angst, dass ich meine Printf-Funktion neu schreibe, wenn ich nicht passiert.
Ist es denn soweit verständlich oder ist das schon zu hoch, wie ich jetzt begriffen habe?
Mal schauen.
Okay, okay. Ich glaube, man muss es 2- oder 3-mal sehen oder hören, bis man es so richtig drin hat. Aber
Ist auf jeden Fall mal was Neues.
ja, ich meine, im Internet steht hier sonst nichts, was irgendwie objektorientiert mit C ist. Alle schreiben dann den gleichen Kram mit STR-Join und so.
Ist ja gut, wenn es was Neues ist und lernt man auch was Neues, dass man vielleicht dann
Deswegen
gleich
sind wir hier.
andere Funktionen ausprobieren kann.
Okay, ready to continue?
Yep.
Nice. Watch out.
Yeah.
I think there's also Anna.
Yeah.
Okay, so what we were just
Can we
talking
wait
about is
1 second more? Anna
oh yeah, of course.
was there before.
Let's do 1 or 2 more minutes, and I think in that time I can just summarize 1 or 2 points. Literally points. Okay, so what we just had again was we had the concept of encapsulation. So basically keeping the implementation of objects kind of separate from their representation. And why do we do that? Because our C language is quite limited in what it can do. So we use objects to add more expressiveness. We were just resuming, so no worries. So again, representation and implementation are decoupled so that we can add some kind of layers on top of the C language which make it more powerful. For example, we had the thing with the strings, like the string A, B, C, D, E, F, and G, I don't know. And you want to join them. Again, you would have to write a function to join 3 strings, theoretically. This leads on nicely to something that I'd like to show you that might come in handy in the getNextLine project for the 42 year. Because, do you all remember the task of getNextLine?
Starting it right now, so I don't know.
Okay, so the task of getNextLine is basically you have a file in your system that sits somewhere on your disk. You don't know which file exactly it is. And let's suppose you have a file descriptor that currently points into that file. Again, a file is just like a pretty long string. It's just a bunch of bytes. If you have a new line, this is basically just another character with a \n. So technically, it's not a file that's 2-dimensional, as most editors show it to us. It's basically just a pretty long string, which can be many gigabytes in size. And now our problem is, we want to read this file line by line though. So somewhere in here there might be \n's. Sometimes they are following directly on each other. And what we want to do is we want to read every single line. So I want to get this line as a string, then I want to get this line as a string, and I want to get that line as a string, and so on. Okay? Makes sense? So we have a function, or we are going to write a function which is called get next line, which has this file descriptor as input, so we have to tell it where exactly we want to read from. We can give it 0 for the standard input, we can give it some kind of file that we open, we can give it every single file descriptor out there. And it's going to return us a char pointer of the line that we have read, or if we are at the end, it's going to give us null. And if we call this once, like we have our main function, and we call get next line on file descriptor, let's call this just fd, we don't care about which one. And then I'm also going to abbreviate this to GNL, so don't be surprised. It's the same function though. And we call it again, and again, and we close that. This one is going to return the first line. The next one is going to return the next line. The next one is going to return the next line, and so on, until the last one is going to return null, because the file is at the end. And now what we can do, for example, if we want to write out the entire file, what we can do is put this in a while loop, which basically prints until the result is null. Of course, this line is allocated. It's like a string duplication or something, because this already exists, and we cut them out basically. It's like a string duplication or a substring basically that takes this line out, copies it over, and returns that over here. So, but we still get it line by line, and the task is to basically write such a function. And you might already see a tiny bit of object orientation here, because this is like opening a file descriptor, then reading from it. We are now, if we put in a different file descriptor, this function will also read from a file, from standard input. So basically this function behaves differently depending on the object that we're going to use this function on. Okay? Is that clear? I see many faces, but not all of them are nodding in approval.
I didn't actually get the point.
Okay, this is the idea of get next line. If you've got that, let's approach this problem. What many people do when they want to write this get next line is, well, they read some amount of data from this file descriptor using the read function. So it's basically read from the file descriptor into some kind of buffer that exists somewhere in your system. We don't really care where that is, but just for the sake, we read 42 bytes from this file descriptor and get them out. Now these 42 bytes might be part of the first line. If the first line is longer than 42 bytes, then of course the problem is, well, if it's longer, then we're only going to get a portion, but we need, of course, another part of it to return the final string. If it's longer, we might already be reading some part of the next line. So we don't know in advance how big we need to choose the buffer, because we need to read first until the \n in order to select, well, how many bytes to read. So this is a problem. So what most people do is they set up a string which starts out empty. So they have a string that starts out empty, and let's suppose they read part of a line. So they read A, B, C, but then we also have D, E, and then the \n, and they only read that. So what they are basically doing is they read this, put this into the string, and then they read again until the string contains a \n. Okay? So they basically, okay, no \n in the string yet. So what we're going to do is we're going to read the next block, which is again 3 bytes, and append it to this. Again, string appending. This is already tying into the string join problem that I was talking about. So they join this string basically and that string again. Maybe there's some other bytes following it, so this doesn't have to be the last one. But let's suppose it is. D, E, \n. There we go. It contains a \n, and luckily it's the last character. So we can just return this build string and then cross that one out and use a new empty string for the next row. That's the basic idea that many people use. Now the problem with that is, let's suppose we do this. A, B, C, D, E, F, \n, and then we have G, H, whatever. So when we read the next block, it doesn't completely align with the \n. We might be having some kind of other data from the next line inside of our read data. So this is what we are going to read here. The problem is, well, now we have some data left over. So what we need to do is, in order to return this is what we want to return, of course, right? This is what we need. Only the line always ends with \n. Now what people do is they use substring. They cut this string out, copying it all over again, A, B, C, D, E, F, \n, and then they do another substring for G and H, cutting this down into another one, throw this one away, make this one the new string like this one that we previously had, and then return that one. How many memory allocations were in that process? Quite a lot, right?
But don't
So-
you free after you allocate?
You're free, of course, but you have to remember to free. And so technically, if you allocate 2 times or 3 times, you have to free 2 times or 3 times. So the problem is, just as we had with the strjoin function, you cannot write, let's say you want to split this string. You can't just do something like strjoin, like we also have to join these two together. We can't just strjoin s1, s2, join, and then s3. Because this one will then leak. So what would we have to do? We have to make our code bigger and then put the free explicitly in there. And of course we can free